It's my great pleasure to introduce our keynote afternoon speaker, Professor Jay Lund. My name is Lauren Adams. I'm another IGERT trainee. I'm lucky enough to be one of Jay Lund's students. And Jay is the director for the Center for Watershed Sciences, a professor of civil environmental engineering at UC Davis. He'll be bridging the gap between the morning session, where we defined groundwater problems, and the afternoon session, where we're going to start articulating solutions to these problems. Jay's had an illustrious multi-decadal career in water management in California, leading research investigations that define the problem, as well as training water professionals in building useful models to dig into the solutions. So thank you, Jay, for joining us and sharing your knowledge, wisdom, and insights.
Thank you all. It's a pleasure to be here. It's really an honor to be here. And when students that don't have to invite you, that's really nice. This is a really hard topic to talk about right now because it's changing so fast. And I think you get a flavor of that from some of the early morning talks. And even if you read today's Sacramento Bee, the op-ed page of the Sacramento Bee had a really excellent op-ed on groundwater policy in California. So I think we're in a drought. Droughts always accelerate things. We have a chapter in one of our books on California water. The chapter is on the history of California water, and it's called Floods, Droughts, and Lawsuits, because it's really floods, droughts, and lawsuits that precipitate change. And we're seeing that, I think, in the groundwater area right away here. So the title of my talk today is, maybe a little bit hopefully, groundwater, or California will adopt and quantify groundwater management. We certainly have groundwater management now in a sense, but in most cases it's not quantified and it's not really management in many ways, from an engineering perspective at least. So sort of a quick outline, I'd like to talk a little bit about where groundwater policy in California is now, some of the major problems we have now, drivers of change to this problem, where we're going, maybe a little bit about how we might get there and some of the mechanisms for change, some conclusions, and of course, since I'm a professor, I'm going to give you some further readings. Here's the view I'd like us to take of California water. I'm going to spare you a couple of slides on hydrology because you're all from California and you know it's dry outside now. Normally when we look at California water management, California water infrastructure, we look at it from the view on your left, from the surface water side, coming down from Mars. This is how the Martians would see it when they were invading us, right? Whereas if you were coming up from the center of the Earth, how would you see California's water management? You would see it from the view on the right. You'd see these massive formations of groundwater, right? That's what you would see first before you got to see the surface water. And some of those things have been talked about, I think, a little bit already. But I think we should try to integrate these kind of views, one that's really surface water centric, maybe a little bit more historical, and one that's pretty heavy on the groundwater side. Groundwater is, I think, really interesting. As a systems engineer, I find groundwater to be particularly interesting as a component in a water management system, regional water management system, state management system, in that it performs quite a few different roles in that system. Some people will focus on storage, some people will focus on quality and different things, but I'd like to sort of review sort of 5 major functions that groundwater plays in a water management system. First of all, it collects water. It's like a paved hillside or something like that. It collects precipitation, it collects stream flow, and it provides a venue for reuse. So an awful lot of the water that we apply on fields is collected by groundwater and is available for reuse because it's collected. And so I think we should bear in mind all of these sort of collection functions when we manage groundwater and we talk about storage. It also stores water. It stores water in several different time scales. It stores it on a seasonal time scale. In most years, it's not storing much seasonally for this year, but from wetter seasons to drier seasons. It stores water from wet periods, wet years to drier years. And in some ways, it stores it over geologic time, which is what we call mining. You know, so just like we mine oil and things like that is stored over geologic time, we're mining oftentimes water that's stored over geologic time. It conveys water to local pumps, so in addition to collecting it, it also provides conveyance to collect water and bring it to a local pump or to a stream or a spring. It's also a drain. On the downstream side of our water management, we also use it as a sink for excess water, as a way of draining water, as a way of leaching salts out or draining salts out of the system, draining nitrate out of the system, and all kinds of other things that are in our return flows and our wastewaters. And then finally, something I hadn't really appreciated until I started working with more ecologists and biologists is the degree to which groundwater tables support riparian and wetland habitats. You know, they're essentially, you can imagine to some degree these habitats floating on top of the groundwater in some sense. And then when we lower those groundwater tables, we basically undermine those resources. And then for California, just to give you a sense on the relative numbers, look at the storage capacity of water in the surface and underground. The numbers for the underground side, they vary tremendously, but they're all much larger than what we have for surface storage. When we look at droughts in California, if we have a 6-year drought, say the first couple of years we're getting through it mostly on surface water, but the last 4 years it becomes overwhelmingly on groundwater. So we have to really keep that in mind, I think, if we're thinking about droughts, which is what many of us are doing at this time. In terms of the seasonal storage magnitudes, surface water, we store between 5 and 8 million acre-foot a year, typically on the surface, and about 3 to 6 in groundwater, in terms of the seasonal fluxes that were shifts from wet seasons to dry seasons. In droughts, we might have 15 to 18 million acre-foot of water storage during a drought that's taken out during a drought from surface water reservoirs and a fair bit more from groundwater. And the longer the drought, the bigger the proportion of groundwater becomes. And then this, I think, is also reflected in deliveries. Surface water is most of our water deliveries, but groundwater is important, and it becomes more important, maybe even up to 50% in some years during a drought. And the picture, of course, on the right is just to remind us that all these things are connected. Surface water, I often tell people that there's no such thing as groundwater in the Central Valley. That's mostly stolen surface water because it is so connected with surface water. Where's groundwater policy now? It's largely laissez-faire. Certainly, if you look at it, the proportion of the surface of California and how it's managed. We have some fairly tight groundwater adjudications and management in some parts of Southern California. We have some water replenishment districts in areas like the Santa Clara that also manage water fairly tightly. Some parts of the Central Valley, some large parts of the Central Valley are managed pretty tightly with, by managing the price of surface water. So if you charge farmers for surface water a price that is just a little bit less than the cost of pumping groundwater, what does the farmer do? They'll take the surface water. And then during a dry year, when there's no surface water to be had, what does the farmer do? They'll pump groundwater. This is a conjunctive use operation that requires, the only management that's required is setting the prices right on the surface water. And for many parts of Central Valley and the agricultural areas, this balancing has worked pretty well for several decades, although it's always a little bit of a tenuous thing, and we might see it under threat in the future. We have quite a few county no-export ordinances, and we're having a few counties that are trying to curtail new well permits in order to reduce some groundwater overdraft in some areas. And what we really have ultimately, I think, and that will drive us away from the status quo, I think, is insecurity of groundwater rights. If you are a farmer out there that is growing permanent crops, you're not sure if your neighbors are developing the groundwater that you're going to have groundwater available during a drought. And this is a big economic threat to you. And so I think this insecurity is going to be something that motivates us into more management in the future. Some of the major problems we have the undermining of surface water flows. Again, this comes back to there's no such thing as groundwater in much of California. It's really stolen surface water when you pump it. What you're doing is you're lowering the groundwater table, so you're inducing more surface water flow into groundwater. So some junior surface water right holder now has less water because someone else is pumping, maybe it's even the same person, is pumping groundwater. Undermining in another sense in terms of loss of riparian and wetland habitat. We also have some areas that have quite a lot of overdraft. Spajaro Valley, I know was mentioned earlier. Probably the biggest overdraft area, certainly in the state, is Tulare Basin, which uses about 15% of its consumptive use in the Tulare Basin comes from overdraft. Doesn't seem sustainable in the long run in many senses of the word. We certainly have localized contamination of groundwater and sort of the traditional urban contamination plumes that we studied so much, those of us that were graduate students in the 1970s and 80s. Regional contamination is something I think that we need to be more cognizant of. We have basically several million acres of plume for nitrate in the Central Valley, and these are going to be expanding and spreading with time. We also have several 100,000 acres of essentially salt plumes coming from irrigated agricultural return flows and the like. I mentioned loss of riparian and wetland ecosystems. Land subsidence, something that's in the news and causes some local problems with flooding and canals. I always find that the drought impact of land subsidence, the real problem of it is a flood control problem in many cases. And then I think at the end, we have this insecurity of groundwater and discharge rights. If I'm conducting an agricultural operation, an urban operation on the surface, I want some security in my operations, in my costs, so that I know what can be done over time and whether I should invest or not. I think it's important to notice that essentially all of these problems are local and regional in nature, and that they vary considerably between different parts of California. And I think for management that has a lot of implications. So out of these problems, I think we have quite a few drivers of change for groundwater. Up until I think very recently, most of us have been thinking, well, it's impossible to change anything, but I think if you look at the history of California water, looking at it from a little larger time scale, you do see that actually groundwater and water in general in California does change despite all of our individual efforts not to change things so far as our local interests are concerned. We have growing scarcity and tightening of management over time. Again, because of overdraft, accumulations of nitrate salts, all kinds of contaminations, mostly from irrigation and agricultural practices. Over time, we're going to see more environmental flows. And so let's say we're increasing environmental flows. We're going to go to different tributaries in California and insist that they maintain more stream flows. And we maintain more stream flows into the delta and maybe going out of the delta. What are you going to do if you're up in the Central Valley, you have a very large operation, you're used to getting some water from surface water, and that's being curtailed because you're now being required to leave that water in the stream, some of that water in the stream. What's a businessman going to do up there? You're going to go out back and turn the well on. Where does that well water come from? It's stolen surface water, remember. It's eventually going to come from depleted stream flows. So at some point, maybe it'll take a few years to develop, that increased groundwater pumping is going to come back to haunt the surface water and including the environmental flows. So ultimately, this is going to push us in to do the accounting a little bit more tightly with groundwater. Surface water rights encroachments. That was sort of what I was getting at before. Ecosystem support for from aquifers. I mentioned that before, and then the security of rights. And then also similarly on the water quality side, I'm going to need some security on water quality for me to continue investing in agricultural production that as a byproduct produces nitrogen contamination to the groundwater. And then the final thing I think that will drive change, and that we're seeing a lot in this drought, is that permanent crops require groundwater in order to survive a drought. That's the biggest source of storage in the system. A third of the irrigated area in California is now in permanent crops, fruits, nuts, vines. So 3 million acres out of 9 million acres. That's a growing proportion and a very large proportion now. Water scarcity. There's a phrase among water economists that I really like that says that there's never a shortage of water, there's just a shortage of cheap water. And I have a wonderful colleague, Richard Howitt, who says, there's a shortage of sports cars, I don't have one. Right. How many of you are suffering from a shortage of sports cars? Okay. Everyone would like to have more water, more money, more land, more sports cars, right? That doesn't mean there's a shortage in some dire sense. It means there's not as much as I'd like. And we have lots of resources in our economy and in our social system that we have to view this way every day. Sometimes there's a shortages of chairs in the room. They stand in the back, things like that. What happens when we have growing scarcity? We live in a semi-arid climate. My gosh, we ought to expect water to be scarce, right? We have tighter definition of property rights. So over time in the history of California, we've gotten tighter and tighter with our management of surface water rights. And in this drought, we're going to see that tighten some more. We see higher prices. If you look at the market price for water, it was mentioned earlier today, there were some numbers being bandied about the market price of water these days during a drought. And just think about how low it is during 1997, a flood year. And when we have more scarcity, there becomes greater value from trading water back and forth, from lower value uses to higher value uses, and more value for conservation. Okay. Same thing. How many of you considered buying a smaller car when the price of gasoline went up? Okay, see, that happens too. It happens in lots of realms of liquid resources, not just water. Here's groundwater overdraft. I don't need to spend too much time on this. Most of it's concentrated in the Tulare Basin. We have a few other isolated places. And there's some ideas that perhaps this overdraft is now spreading with the higher commodity prices for crops and some expansion of agricultural land areas and some intensification of agricultural in some parts of the Central Valley. Accumulating salts and nitrate. This accumulation of salts might affect maybe as much as 500,000 acres in the southern part of the Central Valley. A lot of that extra salt is coming in from the Delta. For nitrate contamination, we just finished a really wonderful study here a couple of years ago now in the Tulare and Salinas basins. You can see from this map, basically any of the lighter green, anything that's not dark green in this map has a loading rate of nitrogen that would exceed the nitrate contamination standard for drinking water. So you can imagine that if not now, eventually almost all of the Central Valley, or certainly this Tulare Basin, is going to suffer from nitrate contamination of drinking water supplies. And if you look at the chart above, there's some modeling results that Thomas Harder and others did, showing sort of extrapolating out with model results showing the growing proportion of wells that'll exceed drinking water standards for nitrate. We also have irrigation mobilizing some natural contaminants, perhaps arsenic, uranium, other things I've heard talk about. These are really major problems on the water quality side, contamination side. They result primarily, if not overwhelmingly, from agriculture. The state is really the only one in the regulatory role, both of the state board and the regional boards. These are also cases where the cost of source control will be prohibitive and ineffective in terms of resolving the water quality issues in a timely way. It takes many decades for source control to affect nitrate contamination in groundwater, just like it took many decades for it to develop. And so essentially what we're looking at on these water quality sides is managing inevitable degradation unless we want to put all those people unemployed in those agricultural areas. I mentioned lowering water tables over time, establishing a new equilibrium condition. There's a picture in the upper right is of a former artesian aquifer. We have very few of those left anymore, and we've seen the different effects from that. Let me sort of spin through these. We mentioned some of the ecosystem effects. And then water rights insecurity. So when you're not sure if you have rights to water, how much are you going to invest in water-dependent activities? How many of you would ride your bicycles to campus if you weren't allowed to use locks on your bicycles? If you drove to campus and you weren't allowed to lock your doors, how many of you would drive to campus? How many of you would own a car if you weren't allowed to lock it? This is the problem we have with groundwater now. People eventually are going to find that because you don't have ownership rights, or your ownership rights are insecure, that maybe you're going to have some doubts about whether you're going to invest in that more profitable crop, that permanent crop that's going to need to have water reliability to get through a drought. Some very definite economic impacts will come from that, and I'll go through an example later. Similar side, on the water quality side, we have some values to having security here. So I think in the end, we're going to have change in groundwater policy in California. The question is it going to be a little change or a big change? Let me go into this permanent crops issue just for a moment here, because I think it's quite interesting. The diagram up here to the upper right, let me try to use this. Here we have a surface area in the Central Valley that has some permanent crops and some annual crops. In wet years, I irrigate both crops, and some of that irrigation recharges groundwater. And let's say the only water that flows into this groundwater is recharged from aquifers, from irrigation, which is true in a lot of the cases. And then during dry years, I pump from groundwater when I don't have surface water. And the first priority, of course, from that groundwater is going to be to keep my permanent crops going. So this is kind of a system, and this is the system essentially for the western side of Yolo County and a lot of Kern County and much of the Central Valley. It relies on recharging in wet to withdrawal in dry years. And the fewer wet years you have means the more dry year fallowing you have to do in order to keep the system in balance. And of course, if you don't keep the system in balance, it means you're pumping for annual crops and permanent crops in dry years as much as you supplied them in wet years, and then you draw down the groundwater basin. So if you're going to keep it in balance, you're going to have more dry year fallowing of the annual crops to preserve your permanent crops. So this is sort of a little diagram. I've got some spreadsheet calculations behind it, that as the dry years become more probable, which means the wet years become less probable, in order to maintain the hydrologic balance in the groundwater, you have to have a smaller proportion of your crops be permanent. Okay? So more of the surface area here is in annual crops and less in permanent crops, because in the dry years you will follow the annual crops to keep the permanent crops alive. As we get more and more water scarcity, you can expect to see essentially and functionally more and more dry year probability. And this is what happens if you're optimal about following annual crops, which means you have some water right allocations that you can trade around, and you don't have a tragedy of the commons occurring with the groundwater. If you don't have that optimality and you have a tragedy of the commons, then essentially somewhere in here you get to a point where you can't rely on there being enough groundwater for your permanent crops during a drought, and so all you ever do is grow wet year crops. And then you do very little irrigation in dry years, which between the wet year impacts and the dry year impacts really lowers the overall region's economic productivity and profits. So over time, this insecurity reduces permanent crops and reduces the overall profitability and the economy in the region. I think that's the kind of theory that we should be looking at now for the Central Valley, and I think the rise of permanent crops in the Central Valley gives the owners of land and the owners of permanent crops a lot of political and economic incentive to be interested in groundwater management. And to me, that's a really big turning point in this public discussion. Is now agriculture, or at least a big chunk of agriculture, a third of the land area and the most profitable third of the land area now has some interest in groundwater management. Whereas in the past, it was black helicopters and things like that in some circles. Different forms of groundwater management. We have laissez-faire. These are sort of listed from sort of informal to more and more formal. We have surface water pricing to manage groundwater use. I mentioned that before. Large irrigation districts, semi-tropic, Arvin Edison, they are big enough, they sort of manage groundwater by their processes on the surface. Irrigation districts that pay groundwater users, pay some of the users to use more expensive groundwater so they can sell surface water at times. Glen Cluse Irrigation District, Yuba County Water Authority agency have done that at times. County well permits and export restrictions, Butte County, a few other counties have been doing some of that. Water replenishment districts, Santa Clara Valley Water District, Orange County, Pajaro Valley, these are becoming more common. And then court adjudications, which are mostly in Southern California. And again, as was mentioned earlier, these arise mostly out of people getting desperate enough that they're finally going to come to an agreement, and then they'll get the court to stipulate to it. So I think we're going to be moving down that list, sort of shifting the distribution of management down that list a little bit over time. Where are we going to go towards? More locally led groundwater management. I think it will always be locally led, but the state is going to provide, I think, more of a backstop. In all of this discussion, I think something that I've only just came out the last week or so is this document from Aqua. How many have seen this recent document from Association of California Water Agencies? Hopefully Tim Quinn will talk about this, called Recommendations for Achieving Groundwater Sustainability. How many people have seen this? Okay, you should read it. I think it's one of the most remarkable groundwater documents I've seen in California from a policy perspective. And it goes sort of along these lines, which is along the lines of what a lot of people have been thinking off the side for a long time. They've put together a very cogent argument and proposal. And so it has a state backstop regulation in the spirit of what we sometimes call cooperative federalism, where the state is going to force you to do something at the local level, but you're really glad that the state is forcing you to do it, ultimately. Sort of, it's the way we handle drinking water regulations and water quality as well, where the feds require us to do it and the states implement it. This is going to have more quantified and secure groundwater rights, more defined pollution rights and costs, more groundwater regulations to support ecosystems or some kind of arrangements in that. And in order to make this all work, you're going to have more information, better well log access, modeling and data, more active and effective water markets, because we have a dynamic economy that needs markets to sort of move resources around. And we're going to have more groundwater integration into portfolio management, which is where most of us are going and have been going for some time. And I think on the politics of this, it'll be the tree and vine farmers that'll take a leading role, at least on the agricultural side, because they're usually very well organized. Some avenues forward, I think things can go in one of two ways. Either there could be an integrated package, and this Aqua document, I think, has a really very thought-provoking and very detailed, precise kind of proposal. And if that fails, I think we're still going to see this pressure, this irresistible drivers of change coming along, and we're going to see sort of piecemeal, step-by-step kind of, and sometimes there'll be 2 steps forwards, 1 step back kind of things, in a lot of little smaller fronts, but all leading in a similar kind of a direction over time. And maybe it'll take another big drought or something like that, but I think we will see some big changes. In terms of overall conclusions, unmanaged groundwater is now a threat to agricultural and rural prosperity as well as to the ecosystems. These haven't been the usual quarters from which groundwater reform and policy have been advocated. I think this is going to really reshape the kind of discussions we have and the kinds of policies. We're going to see integrated water portfolios that include groundwater, which is a continuation of a trend that goes back, you can go back actually to the Harvey Banks' work in 1950s. You can see sort of precursors of this kind of thing. Local and regional groundwater management is going to be what's prevailing. I don't think the state agencies themselves are willing or able to come in and manage local groundwater. They'd be fools to try to step into that mess. It's the locals that really need to be organized and given authority to be organized and being given authority to fund these kind of activities. The state is going to have several important roles in this as a provider and guarantor of information, as a guarantor of agreements, and as a backstop to make sure that local enforcement and local actions are done well. And then, as I promised, some further reading, which I'm sure you can have done by the end of the class today. And with that, I'll stop. Thank you very much. Any questions? This is after lunch. Reed.
Thanks for a great talk. This is probably a kind of a naive question, but I'm curious about the answer anyway. So,
is the microphone?
This microphone up.
Actually, you can repeat the question. So,
You just said that your question was naive?
I think it might be a bit of a naive question.
My answer will be naive. Don't worry.
Fair enough. So I'm curious about the idea of tributary groundwater in Colorado, which is managed very differently than non-tributary groundwater or fossil groundwater, and that notion in California, because you mentioned, of course, that you're really just stealing future surface water when you pump groundwater, and a lot of the groundwater surface water interactions issues. So I was wondering if you could comment on the difference in management between the two states and how that's thought of, because there is an explicit thinking of you cannot pump tributary groundwater because that's surface water that doesn't belong to you in Colorado.
Right. Well, I don't know as much about Colorado water rights as you do, but I think they are very different philosophies. In the sort of Western states that have a state water engineer that's supposed to keep all the mass balances, which is sort of a useful fiction. Necessarily a useful fiction. There's a very tight relationship, and you have to prove you're not harming someone else before you get the right to use it, whereas we sort of turned it on its head here, that someone else has to eventually prove that you're harming them by taking this water and that you don't have the right to do it, and it will probably take you a century to make that point. So you're not going to live long enough to get your satisfaction in California in this case. So I think we have to move towards the Colorado, something closer to the Colorado model. Eventually we're going to have to quantify these kind of rights and keep some kind of accounting for them. That accounting will always be controversial and imperfect, but we will be better off with that than not doing accounting on it.
So I think this is really interesting. So do you think that that's feasible, though, given the current setup? Do you think it's so necessary that it's going to have to happen, or do you think?
I think we will creep into it basin by basin. And certainly in the adjudicated basins, there are water masters who keep the balance, who keep the accounting sheets. And we'll move into it basin by basin. Every basin will do its accounting a little differently. But I think eventually we will all be happier that there's some sort of a state accounting system and quality control. Those of you that own a house, we're all very happy that the county keeps the records for the property lines. So when my neighbor starts to build his fence a little too close, or that we know who to go to, there's somebody in authority to keep the accounting straight.
Great.
We're all glad. I think ultimately the Department of Motor Vehicles keeps track of who owns my car so that someone else can't claim it too easily.
Great, thanks.
Oh, sure. I didn't see you on the other side.
So I am a fledgling economist, and I've read some of the work by Ellen Hannock and Richard Howitt, who's in my department. One of the popular ideas as far as surface water goes is water trading, regional water trading. So regional water trading, as far as agricultural use, might create an incentive to sell water at a higher price. It might create a higher market clearing price. And if that price goes up, then you might sell your surface water, which then makes groundwater pumping much more attractive. It kind of goes to the second point you brought up about increasing management, and you were talking about Yolo County pricing surface water just below the price of groundwater. So I was wondering your thoughts on if surface water trading was a good idea from the perspective of groundwater management, or is it something that we should maybe avoid?
I think it's great. California has a dynamic economy, and we have a highly variable supply, and we have highly variable demands in space and time. If we don't have a a way of moving water around, moving a scarce resource around the system in space and time with low transaction costs, it really harms the economy and harms the prosperity of individuals throughout the system. So I think water marketing is a far better way of moving that resource around than lawyers, in terms of lowering transaction costs and the time and risks it takes to get a transaction to occur. One of my favorite examples is occurred in the 1990s, Southern California coming into a drier year, what they thought was a drier year. They wanted to buy some water from Yuba County Water Agency and Glen Colusa Irrigation District up here. And what in this case Glen Colusa did was they said, well, we have this very senior surface water right. What we would like to do during this dry year is to sell some of that surface water right down to Southern California. And we have some farmers in the Sacramento Valley with wells and very full groundwater basins. And what we will do is we will pay those farmers to pump some groundwater, pay them the difference for the surface, more than the difference, so that it'll be profitable to them. And then we'll send that water down. And so what you basically had was this water marketing system that created a conjunctive use storage system, all locally done without the state and federal governments getting involved very much. The Metropolitan Water District, when they bought that water, once they had already contracted for it, it was already moving down the system, they realized they didn't need it all. They had too much. So what are they going to do? Well, they found an irrigation district down here, Tulare Basin, that had overdrafted its groundwater basin tremendously over the course of decades, and they realized, hey, they have a resource, empty pore space. And they paid the irrigation district down here to store the extra water. So you had this market transaction providing very efficient incentives for all these locals to cooperate. If you had forced them to cooperate, they would have fought you to the death with lawyers. And nothing good would have come out of it. Whereas out of this, you got a happier urban district and 2 happier irrigation districts because of it. So I think if properly done, these kind of market transactions are very useful for the system, and they sort of civilize the conversation and the management of the entire system.
Okay, thank you.
Hi, I'm curious about, in the interest of quantifying this, looking at, in terms of recharge, are there examples of metering as you pump in rather than out? And, on a local level, we're looking at, experimenting with that.
My doctoral dissertation was on water meters for urban water systems. And it was weird that I came down here to a place of the country that had no water meters at the time. But it was very interesting when I was doing that study to realize that urban water meters are often off by 1% or so. And it really impressed on me that water meters are good, but they're always imperfect. All field measurements are imperfect. Those of you that have dealt with field data know this, I think. And so when we talk about metering, I think we have to keep in mind that often these are, again, sort of useful fictions, approximate truths. For recharge, we estimate recharge. We don't really measure it. We can measure it we can perhaps more closely measure it at 1 square centimeter where we might put a probe in, but across an area that has heterogeneous soils and infiltrations and things like that, these will always be approximations.
So if there's a pump involved pushing it back into the aquifer, that's not measurable at this point, you think?
It's measurable but approximate.
Approximate, okay. Thank you.
Yes?
At the north end of the valley, some of us have canal water and some of us have only well water. So what's happened is that the people with canal water have been drilling wells, and now they're going to sell their surface water and pump groundwater.
Right.
Some of us who have only groundwater know that that's going to at least raise our cost and may maroon us.
That's right.
Without any water.
That's right. So I think in that situation you have some incentive to quantify the rights on that system.
Ah, but they have no incentive to quantify our rights.
They eventually should, because they're going to rely on that groundwater eventually as well.
Well, that's not the way they look at it.
Well, I don't think for a second that this is not going to be contentious. I just think it will be less contentious than we currently think, and that there will be a steady pressure to move it in a more regulated, more quantified direction.
During the drought water bank in the early 1990s, one of my neighbors went to one of the surface water district people and said, "Your pumping is lowering my water level and raising my costs.
That's right.
And my bowls may very soon break suction."
Right. That's right.
I could lose my ranch.
That's right.
And his neighbor, with whom he went to church, said, "Good, then I can buy your land cheap."
Well, you know, Yuba County Water Agency had a similar kind of a problem when they first started to do a similar kind of a groundwater conjunctive use operation, where they would sell surface water and have some of their surface water contractors pump groundwater. And what they did is they went into the area that was going to pump more, and they made an offer. Anybody in this area that feels like this is going to reduce their groundwater level below their wells, leaving you high and dry, if you think that's a problem, come to us, we will drill you a new well. That was, was an offer by the agency to make sure that nobody was stranded that way. And I think, you think initially, well, gosh, I'll bet everybody took them up on the offer, but you only have to do that once if you manage it correctly. If you're not making this into a permanent overdraft situation, if you're managing it as a true conjunctive use operation. So anyway, there are ways, I think, to work on these problems if we decide to get organized to go after them. But your point is well taken that it will be locally controversial in every little local basin, but I think you're going to have to, that's one reason to have the state come in and insist that people get organized.
Precisely.
This is going to be the last one.
One last one? Okay. Well, I have a couple comments. One is I wished I shared some of your optimism about getting people on board, that the drought will force us to limit pumping in some ways.
One thing I realize is that pessimism is always self-fulfilling, and optimism sometimes is.
Well, because I was just reading in the paper the other day where growers, instead of getting together talking about trying to limit pumping, they're going out and buying drill rigs because they can't get their wells drilled fast enough. So I found that.
It did occur to me that as this director for the Center for Watershed Sciences, that maybe what we should be doing is just close shop and go buy a drill rig this year.
You can make a lot of money. Going back to one of the comments you made, though, and what was just stated here, we've done some work, as you know, looking at the Central Valley. We're trying to illustrate better. I'm working for the Nature Conservancy. We're doing work trying to show better what Jay's talked about, which is the linkage between groundwater pumping and surface water impacts, because we're trying to protect the environment, because people are pulling out the rug from under it unknowingly by pumping groundwater. And what I want to get at is, you were talking about the groundwater substitution program being a positive thing, and it certainly can be. But as you also said, we have to realize that when we substitute it, that groundwater pumping ultimately comes at the expense of the stream. And some of the new work, some of the new ground that we've broken shows that pumping takes between a few years up to 20 and 30 years. So what we see are these impacts spread out over 20 or 30 years. Right. So the reality is it isn't like it comes back into balance. We're actually taking water out of the stream long term. So we need to account for that.
That's right.
But more importantly, I just want to leave you with this, especially the gentleman that just talked about it. We're pumping about 2.5 million acre-feet of water a year out of the Sacramento Valley. That's coming out of the streams, like Jay said. We see about half of that already expressed as lower stream flow. When you model it, you can show about 1 million acre-feet per year less stream flow right now. That wasn't accounted for, right? In the Sacramento River.
If you're a junior water right holder, that water's been stolen from you.
It's been stolen. That's It's gone. And if you're worried about delta water rights and delta flows, it's gone. And if you're worried about exports from the delta, it's gone.
Right.
So this is really playing out on a large scale. In other words, there's less water at the delta now because it's being short-circuited. I don't want to say it's not right from a water rights perspective, but this is not just local issues, right?
Yeah.
Yeah, so.
Absolutely.
Right.
Great. Thank you all very much. And again, I highly recommend that Aqua report. I see Tim Quinn here. I'm touting your report.